Okay, pi orbit by LA. Well, the pi symbol does seem to be in orbit, and it does seem to be by Los Angeles. I have a hard time believing that's what we're going to study. Oh, wait. We are reorganizing, and it looks like we're going to study probability. Okay, so goodbye pi symbol, goodbye Los Angeles, hello probability. So, first lesson in this unit, we're just going to be trying to find the probability of a single event. Now, anytime we work with probability, we're just talking about a fraction. Okay, the answer is going to be a fraction. The numerator, the total number of favorable outcomes. The denominator, the total number of possible outcomes. Okay, so it's favorable outcomes over possible outcomes. Largest answer we will ever get is the number 1. The smallest answer we will ever get is 0. If we ever get a probability of 1, that means the event must happen. If we get a probability of 0, that means the event cannot happen. Okay, so a bunch of vocabulary coming our way here. First of all, we assume that everything is completely random. All right. So if I'm going to toss a coin in the air, I'm going to assume that half the time it'll be heads, half the time it'll be tails. Now, in real life, we know it's not going to quite work out that way, because if you take a close look at the two different sides of the coins, they've got different raised edges, so aerodynamically it's not going to be identical. Also, if it's a stamped coin instead of machined coin, to get stamped coins out of the molds, they've got beveled edges. All right. You probably don't need a microscope. You might just need like a good magnifying glass. But if you look at like the edge of a penny, you'll notice that it's slightly beveled. Where if you instead you look at something like a dime, which is machined, it doesn't have the beveled edges. Instead, it's got those crazy grooves on it. But for what we do, we just assume that it's always fair that half of them will be heads, half will be tails. Or if I roll a die, again, we're going to assume that it's all fair. If you ever go to Las Vegas and gamble when you're old enough to do that, you'll notice that the dice they use don't have like the indentations, because that changes the aerodynamics when you roll one of those, right? So instead, they just have like the lightest coating of paint for the dots without the indentations. You'll also notice that when you go to Las Vegas, if you ever do, that the dice are clear, translucent, so you can see that they're not weighted on the inside. But if we pick up a die and we roll it, we're going to assume that it's fair and that it's completely random and that all the events will happen with the same amount of occurrence. Or if we draw a card from a deck of cards, or if we select a marble out of a bag, or if we select a letter of the alphabet, etc. We're also assuming that it's done at random, that we don't peek, we don't cheat, it's completely, totally random, and that everyone is equally likely to happen. Today is kind of going to probably be the most straightforward of all the lessons, because we're just looking at the probability of a single event. Trust me, it'll get more fascinating as we go on to future events. Okay, so let's find the probability of each event. So we toss a penny one time, and we want to find the probability of tails. And that's how I write probability of tails. Of course, a penny has two sides. One side is considered heads, one side is considered tails. And so I need to know the number of favorable outcomes and the number of possible outcomes. Well, there's two possible outcomes, right? Either it's heads or it's tails. And again, we have to assume that it's a fair coin and these are equally likely to happen. And one of the outcomes is tails, and that's what I want. So the probability is 1/2, right? One side is tails. There are two different sides. Probability of tails, 1/2. Okay, six-sided die. Notice it's a die, right? If I've got two of them, they're dice. One of them, it's a die. Because video games seem to take up so much of our life instead of board games. When I was much younger, it was all board games and rolling dice. If you're not familiar with a die, if it's a six-sided die, we normally would expect to find 1, 2, 3, 4, 5, and 6 as the number of dots on each side. If you play D&D, you might be getting your 20-sided dice, 10-sided dice, 8-sided dice, 4-sided dice, etc. But let's just go with the standard 6-sided die here. So there are 6 possible outcomes. And again, we have to assume they're all equally likely. And in future lesson, we will talk about sample space and size of sample space. But right now, let's just say, hey, there are 6 different sides. Probability of rolling a 2. Well, there are 6 possible outcomes. Only one of them is a 2. Probability of 2 is 1/6. Probability that we get a prime number, 3 out of 6. And of course, we want to reduce any fraction, so that'd be 1/2, and we reduce it. Oh, if you're wondering about why we said 3 out of 6, 2, 3, and 5 are prime numbers. Right? A prime number has exactly 2 distinct factors, 1 and itself. Right? The number 1 is not prime because it does not have 2 distinct factors. Probability that you come up with a composite number. How many of those numbers are composite? Well, there's 2 of them. Right? 4 is composite because besides 1 times 4, there's also 2 times 2. 6 is composite because instead of 1 times 6, there's also 2 times 3. And of course, we reduce the answer if we can. Letter of the alphabet is chosen at random. Probability that I select the letter U. Well, I say 1 out of 26. Right? 26 letters in the alphabet. Only one of them is the letter U. Probability that we select a vowel. 5 out of 26. Okay, Sillyville, here we go. Some things worth noting. That if I forget to state very, very clearly, we're going to assume it's going to be the English alphabet. We're going to assume there's going to be 26 letters. Also, unless directions state something else, assume that there are going to be 5 vowels and 21 consonants. Right? The vowels will be A, E, I, O, U. If you take a look at a math book, I know many of which have moved online, but math books, they love to use letters of the alphabet for probability and permutations and combinations. They always consider 5 vowels, all right? So don't consider Y or W as being a vowel when we're doing this type of work. They're going to be consonants only. Of course, Y, plenty of examples of Y being a vowel. Sky, him, In fact, even the word plenty, that ty, there's a vowel at the end there. W is a little bit trickier to come across as a vowel. Words such as cume, which is like a valley, or a cruth, which is like a little tiny nook or cranny in the house. But it's very common as a silent vowel. For example, the word shop, that's a short O sound because there's only one vowel. But the word show has a long O sound since the vowel O is followed by the vowel W. Right? When two vowels go walking, the first one does the talking. Right? It's one of the things I learned way back in, I don't know, first grade, second grade, somewhere back there. Marbles in a bag. Again, we got to assume that we're not going to cheat and peek, that the marbles are thoroughly mixed up, that we're just going to reach in there. Let's pretend there's 1 red, 2 blue, 3 green, and 4 purple. We're going to draw just 1 marble, and totally at random. Probability that we get red? Well, there are 10 marbles. Only one of them's red. Probability of purple. Now, again, I'm going to start over with a full bag of marbles. So let's not pay any heed and say there was a previous question. Okay, so we ignore what we did when we were looking for red. Now say, probability of purple. Well, if there's 10 marbles in that bag, 4 of them are purple. Probability is 4 over 10. And again, reduce the fraction, please. Probability of blue or green. Ooh, interesting. Well, 5 of the marbles are either blue or green. So 5 out of 10. Reduce the answer. Probability of not blue. Well, I guess 8 of those marbles are not blue. So 8 out of 10, which reduces the 4/5. Again, I'm always assuming that I'm starting with the 10 marbles in the bag. Not yellow. Well, I think all 10 of them are not yellow. 10 out of 10. 1. Again, that is the largest possible answer we'll ever get with probability, the number 1. Right? That means it has to happen. Right? If I reach into that bag and grab a marble, I'm guaranteed it will not be yellow. Probability of orange. Well, none of them are orange. Probability is 0 out of 10. And again, that is the smallest possible answer we can get, 0. Well, you're probably getting a little tired of listening to my voice, so let's cut to the chase. Head off to worksheet land. Something tells me the worksheet's not going to be too horribly time consuming. So even though I got a little bit long-winded on this video, you should still be done with the assignment in a relatively short amount of time, and then we'll take it up on the next one.